Okay, so this is the MAT Specimen paper 1, question A, which says the area of the region bounded by the curves y equals x squared and y equals x plus 2 equals, well, the 4 options below. Okay, so how can we deal with the question? Well, we could first draw a diagram, and that's a very good starting point for any questions relating to equations, lines, and areas. Okay, so we just need a rough sketch. We don't need it to be very accurate, so that would be y equals x plus 2. Fine. Okay, so we then find the bounded area, which is that bit. Okay, so what is that area essentially? So that area is essentially the area under x plus 2 subtract the area under x squared, right? Within the limits, obviously. Okay, so our next step would be to integrate, and we could find the area. Fine. Okay, so the first thing is to find the limits. So how can we find the limits? Well, we solve the simultaneous equations. So x squared equals x plus 2, which yields x squared minus x minus 2 gives 0. So that simply factorizes to x minus 2, x plus 1. Yep. So x would be 2 or minus 1. Fine, so those are our limits there. So I have 2 and minus 1. Cool. So now we could integrate. So we have minus 1 to 2. We need the area under x plus 2. So x plus 2. And we have to subtract the area under x squared. Okay, so we basically subtract the functions to get the area between them. Alright, so that becomes a simple A-level integration question. So half x squared plus 2x minus a third x cubed with the limits, remember. Okay, so what does that give us? So that would be 2 plus 4 minus 8 on 3. Yep. And minus a half plus 2 and minus 1/3. Okay, right, so what do we have now? So 2 plus 4 plus 2, that gives us 8. Minus 8 on 3 minus 1/3, or that's minus 9 on 3. So what is minus 9 on 3? That would be minus 3 itself, and minus a half of cos. And so we have 5 minus a half. So that gives 9 on 2. Alright, so the answer is 9 on 2. Well, we look back at the question. 9 on 2, that would be C.